All right, in this video, we are going to continue with the Conestoga College pre-admission math test. The last time in part one, I ended on fractions, which was the word problem in question number 16. So next, let's go into order of operations. So we're following BEDMAS over here. So brackets first, then exponents, then division, then multiplication, and then finally addition, and lastly, subtraction. So let's start with this first problem over here, 17. I'm going to do the division first because that's going to come first. So I have 12 plus 12 divided by 6 is just 2, and then plus 4. Then I can do all these three additions together. So 12 plus 2 is 14, 14 plus 4 is 18. Let's look at the second one here. The first thing I'm going to do is the division. So 36 divided by 12 is just 3. So I have 3 times 6 minus 4. Next is the multiplication. So 3 times 6 is just 18. And then 18 minus 4 is just 14. Question number 19, I got to do my brackets first. That's the first thing in BEDMAS. So 18 minus 9 is 9. And then 20 times 6, that's just 120. So now I got to do 9 divided by 120. That's a smaller number divided by a larger number. Anytime you have that, means you've got to write it as a fraction. So 9 over 120. And now we got to reduce this down. So what can I divide both of these numbers by? Well, I can divide them both by 3. The way you can tell that is if a number ends with a 0, you just look at the first couple of numbers and see what you can divide that by. In that case, I can divide 12 by 3, which means I can divide 120 by 3. I can divide 1,200 by 3. I can divide 1.2 million by 3. So if you have zeros at the end, just try to look at the first number and see what you can divide that by. So now let me divide these by 3. 9 divided by 3 is 3, and 120 divided by 3 is 40. So final solution is 3 over 40. Last one over here. Again, first thing I gotta do is the division. So 5 divided by 5 is just 1. Next is multiplication. 1 times 15 is 15, and then 15 plus 15 is 30. BEDMAS pretty simple there, just following your basic rules from middle school. Let's get into exponents next. These might be slightly harder, but let's see. Question number 21. We have 10 to the power of 3 times 10 to the power of 4. There's a couple of different ways to do this, but we can either start by just combining the exponents because they're the same term, or we can write it out separately. Personally, I think it's best if we combine our exponents. When we're multiplying two terms that are the same number and we have different exponents, all we have to do is add the exponents. So 3 plus 4 is just 7. And then we got to convert this into a number. So this is just 10 multiplied by itself 7 times. So the easy way to do that is just put a 1 and then I'm going to have 7 zeros. So that's my final solution over there, which is 10 million. Basically, if you have 10 to the number of something, the number over there is just the number of zeros, 1, 2, 3, 4, 5, 6, 7. If I have division and I have the same number here, I have to subtract exponents. So 2 minus 7 is just -5. But now I have to simplify this. You're not allowed a negative exponent in your final solution. So if you ever have a negative exponent, you have to flip it into a fraction and make the exponent positive. So 1 over 2 to the power of 5. And then what is 2 to the power of 5? 2 to the power of 5 is just 2 times 2 times 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. The final solution over here will just be 1 over 32. Next one over here, the numbers are not the same, so I have to do this with just BEDMAS, gotta do it separately. I'll start by doing the bracket first because this exponent here is inside the bracket. That exponent is outside the bracket, so don't do that first because inside the bracket there's nothing to do there. So I'm just going to do the inside of this bracket first according to my BEDMAS. So 7 squared is just 49. Next, I'm going to do my exponent because after brackets comes exponents. These are not brackets, by the way. These are just multiplications here, so be careful not to mix that up. I'm going to do exponents next. So -4 squared. -4 times -4 is positive 16. Now I'm just going to multiply all of these. I'm going to do 49 times 16 on the side. Nine times 6 is 54. 4 times 6 is 24. Put a placeholder for 0. 9 times 1 is 9. 4 times 1 is 4. Let's add these up. 4, 18, 1, 7, 784. So I have negative times 784, which is just negative 784, which is my final solution for question number 23. And last, let's go to question number 24 next. I'm going to do my brackets first over here. So that's just going to be 3, 7 minus 4, 3, 3 squared is just 9. So that's a pretty simple question over there. All right, let's get into some decimals next. We have a decimal addition first. So let's do decimal addition over here. I want to line these up properly. So 0.653 and 1.09. Make sure the decimals are perfectly aligned always. Then we just add from the right to the left. So 3 plus nothing is 3. 5 plus 9, 14. Carry on the 1. 1 plus 6 plus 0, 7. Decimal point is 0 plus 1 is just 1. So final answer is 1.743. Next, we have decimal multiplication. Decimal multiplication, I'm going to do this on an extra sheet over here. We have 4, 5, 7, 5, and then times 12. Okay, so let's see how I converted this to this over here. First of all, in decimal multiplication, I'll never put the decimal places, and I'll explain why. I'll do the decimal places at the end. It makes it a lot easier. And secondly, if there are zeros at the end, never include them because 1.20 is the exact same as 1.2. So it's better to just like scratch that off and completely ignore it in this question because it's not even required for anything. So again, I'll do the multiplication without the decimal places to begin with. 5 times 2 is 10. 7 times 2 is 14 plus 1 is 15. 5 times 2 is 10 plus 1 is 11. 4 times 2 is 8 plus 1 is 9. Placeholder 0, multiply all of those by 1. Then let's just add this up. So now that I've got this number here, 54900, I just have to add the decimal place to it. So looking at my original question, in the first number, I have 2 decimal places. Second number, I have 1 decimal place. So in total, I have 3 decimal places. I'm going to add 1, 2, 3 decimal places over here. Oops. I'm doing a count from the wrong side. 1, 2, 3 decimal places over here. Yeah, 1, 2 decimal places, 1 decimal place, counting from the wrong side. I have 3 decimal places here, 1, 2, 3. So final answer in this question is just 54.9. Next question is division of decimals. When I have the division of decimals, what I do is I like to get rid of the decimals by multiplying both numbers by multiples of 10 so that I can get rid of all the decimals. You can multiply both numbers. In this case, I have 2 decimal places here and 2 decimal places here. I'm going to multiply both numbers by 100. So that will give me 1575 divided by 25. This will give me the exact same answer as this over here. And it's going to be easy to do without having any decimal places. So first I'll look at how many times 25 goes into 157. 25 goes 6 times into 157. 25 times 6 is 150. I subtract that, left with 7, bring down the 5. 25 goes 3 times into 75. Subtract 75, I'm left with a remainder of 0. So final answer to this question is just the top number over there, which is 63. Question 28, write as a decimal 1022 and 83 hundredths. So 1022 is just 1022. Then 83 hundredths. Hundredths is my decimal place. So 0.83. Technically 8 is my 10th place, but because they said 83 hundredths, it's going to be 0.83. If they said 1022 and 83 thousandths, it would have been 1022.083 because that's my 83 in the thousandths place. This is my thousandths place over here. That's my hundredths. That's my tenths. Bit tricky, but hopefully that made sense. Okay, that's the second page completed over there. Wasn't too bad. Let's go on to the third page. Probably going to work on this another 20 minutes or so, depending on topics We get next is metric conversions. So we need to convert the first one, 456 millimeters to meters. So first we got to convert to centimeters. So 1 millimeter, 1 millimeter is really, really small. 1 centimeter is 100 millimeters. So that means it's 0.01 centimeters. Is it actually no, it's 0.1 centimeter to meter is 0.01 because 1 centimeter is 10 millimeters. So to get 456 millimeters to centimeters, I need to first convert that by dividing by 10. So that's going to be 45.6. I just have to move the decimal place once, centimeters. Now to convert from centimeters to meters. 1 centimeter is 0.01 meters because 100 centimeters is 1 meter, which means I have to move the decimal place over here 2 times when converting, which means that if I move this decimal place 2 times, it's 0.456 meters. Next question over here, 1500 meters squared to kilometers square. So meters to kilometers, if I have 1 meter, that's basically, to convert that to kilometers, I know 1 meter is, 1 kilometer is 1,000 meters. If I have meters squared, I have to square that. So 1 meter is 0.001 km, or basically 10 to the negative 3 km if you're thinking about scientific notation. Which means that 1 meter square is 0.000001, 1, 2, 3, 4, 5, 6, yep, km square, or 10 to the negative 6 km square if you're doing it in scientific notation. So basically I have to move the decimal place 6 times over here for this one. So 1, 2, 3, 4, 5, 6. There's going to be 2 zeros here and a decimal point. So 0.0015 km square. Or if you're doing it in scientific notation, you could do this in scientific notation as well too. Maybe I'll show both decimal version and scientific notation as well, because some of the solutions are given in scientific notation. Question number 31 is 36 kilometers squared to millimeters squared. Okay, that's a bit difficult again now. It's going to be a lot of zeros over here. That's what makes me think that these should be done in scientific notation especially. So all the answers are given in scientific notation. So I think I'm going to do these in scientific notation because they're expected to be done in scientific. And if you had multiple choice, I they're going to be in scientific notation. So let's do this first one here in scientific notation. Okay. Millimeter to meter is just 10 to the negative 1. I mean, millimeter to centimeter is 10 to the negative 1. Centimeter to meter is 10 to the negative 2. So if I'm converting from millimeters to meters, that's total of 10 to the negative 3. So I'm doing 456 times 10 to the negative 3. And if I'm doing that, it means that I have to move the decimal place to the front over here. So if I move the decimal place, it's 1, 2 times over here. So since I move it 2 times, I'm going to decrease that by 2. So final answer is 4.56 times 10 to the negative 1 meters. That would be my answer in scientific notation for these questions. I think they intend to be done in scientific notation as well because the solutions are like that. The second one over here, I showed the explanation over here. We're just multiplying it by 10 to the negative 6. So I have 1,500 times 10 to the negative 6. I just have to simplify this now. So decimal place here, move it 1, 2, 3 times. So the number becomes 1.5. Decrease this by 3 times 10 to the negative 3 km square. That's my final solution for that second one over there. Third one over here, I'm going to do it on paper so that I have a bit more space. We're converting kilometers squared to millimeters squared. So let's start by going from kilometers to meters to centimeters to millimeters. So 1 kilometer, gotta multiply by 1,000, which is 10 to the 3, and times 10 to the 2, 10 times 10 to the 1. But since these are squared, so if I'm doing km square to meter square to cm square to mm square, I gotta double all of those. It's 10 to the 6, 10 to the 4, and 10 to the 2. 6 plus 4 is 10 plus 2 is 12, which means that I have 36 times 10 to the power of 12. And then I got to convert this into scientific notation. So 36, move the decimal place once, 3.6 times 10 to the power of, got to always add 1 to this number. And I move the decimal place to the left side. In these cases, I know it looked like I was subtracting the numbers, but I was adding because negative 6 plus 3 is negative 3. It just looks like I was subtracting because I'm in negative numbers here, but we're always adding the numbers when we move the decimal place from the right to the left. Final answer to this question is 3.6 times 10 to the power of 13 millimeters squared. These are definitely pretty tough questions. Hopefully they make sense to you. If not, let me know in the comments and I'll make extra practice questions similar to just these, make them in a separate video so you can understand them with just some conversions. So let's go to the last one over here, which is 125 millimeter cube to meter cube. So millimeter to centimeter to meter. times 0.1. Oh, wait, no, 10 to the negative 1. I'm doing in scientific notation. Times 10 to the negative 2. Then we're doing millimeter cube to centimeter cube to meters cubed, which means this is times 10 to the negative 3, and this is times 10 to the negative 6. So in total, that's 10 to the negative 9 if we add the exponents. So I'm doing 125 times 10 to the negative 9. Now all I have to do is change this into scientific notation. So I'm moving the decimal place 2 places. So 1.25 times 10 to the power of negative 7. I moved that 2 times, so I have to add 2 to that number over there. Always add how many times you're moving to the exponent. The unit here is meters cubed. All right. Next, we have some fraction, decimal, percent questions. I think I'm going to end the video today with these questions from 33 to 36. That's all going to be about a 30 to 40 minute video, which I think should be good. So first one, write 2 over 3 as a percent. Now, a lot of you can probably do this mentally, but I'm just going to do it showing the steps. So if you ever want to write anything as a percent, you just have to multiply it by 100 to convert it into a percent. And then you just have to simplify it. So 2 times 100 is 200, 200 over 3. And then we just have to convert this into a mixed fraction. We can do long division over here. 3 goes 6 times into 20. 3 goes 6 times into 20. And my remainder is just 2. So this is just 66, number on the top, number on the bottom, 2 divisor percent. Question number 34, write 12.5% as a decimal. So 12, 1 over 2. Percent means we want to divide by 100 always. So divide by 100. I'm going to convert my mixed fraction into a regular fraction. 2 times 12 is 24 plus 1 is 25. 25 over 2 divided by 100. Flip the divide into multiply and flip this upside down. 25 over 2 times 1 over 100. Remember, that's just a 1 down there. And now simplify. You can cancel this, make that a 1, make that a 4. 1 times 1 is 1. 2 times 4 is 8. So now I have this as a decimal. I need to convert it into I have it as a fraction. I need to convert it into a decimal. So to convert into a decimal, I'll just do long division over here. It's the only way. So 1, 8. Now we haven't done long division with decimals before, but I'm going to show you how to do it. 8 doesn't go into 1. What I'm going to do is I'm going to put a 0 point over here, and I'm going to add a 0 over here. And now I'm going to do the division. So 8 goes into 10 one time. Minus 8, left with 2. 8 doesn't go into 2, but what I can do is after I've added a decimal place here, I can constantly add zeros over here. I can do that forever if I ever add a decimal place. 8 goes into 20 2 times. Subtract that. So 8 times 2 is 16. Oops. left with 4. 8 doesn't go into 4, so again I'll add a 0 here. 8 goes 5 times into 40 minus 40, and I end at 0. So I can end the question over there because it's now a 0. Which means my final answer to this question is 0.125. Right, is 0.125 as a fraction. So anytime you want to turn a decimal into a fraction, you want to count the number of decimal places, 1, 2, 3. Then you want to rewrite it just the regular number divided by the number of decimal places. So I have 3 decimal places. So I'm going to put 3 zeros over here. Now all we have to do is reduce down this fraction. Remember to always think about dividing by 2 5s or 10s first. Numbers end with 5s and zeros. So I can divide both of these by 5. 125 divided by 5 is 25. 1000 divided by 5 is 200. Again, I can divide by 5s. 25 divided by 5 is 5. 200 divided by 5, 40. Again, I can divide by 5s. 5 divided by 5 is 1. 40 divided by 5 is 8. And that's my final solution over there, 1 over 8. Cannot simplify that further or convert to a mixed fraction because it's basically already in the simplest form possible. Last question, number 36. I'll do this on an extra piece of paper over here. It says 42.5%. 42.5 is what percent of 170? So I always do these in equation form. 42.5 is, that means equals what percent, x is going to be my percent of is multiply 170. So that's my equation right over there. You can simplify this equation. 42.5 equals 170 x, because x times 170 is 170x. And then I can divide both sides by 170. So 42.5 divided by 170. 170 and 170 cancel. I'm just left with x over here. So how do I do this calculation over here? Well, first I want to just get rid of my decimal place just to make things a lot easier. I'm going to multiply the top and bottom by 10. To multiply by the same number, it's going to get rid of the decimal place. So 425 over 1700 equals x. Now all I got to do is simplify this down. That's going to give me my answer. So the other thing I have to do is I need to convert this into a percent. So I need to multiply this fraction by 100 to convert it into a percent. So because the x is a percent in this question. And since x is a percent, we need to multiply the final answer by 100. So I'm going to multiply this fraction by 100 because I think it's going to make my life potentially a bit easier. When I'm multiplying this fraction by 100, I'm only multiplying the top by 100. So that's what my new calculation is going to be. Then I can just cancel off zeros at the end by dividing. So now I just have 425 divided by 17, and this will give me the final percentage in this question, which is a slightly easier calculation. So that goes 2 times over there, minus 34. And then this is a bit of a tough calculation, but 17 goes 5 times into 85. You can't do that mentally. Try and write down the multiples of 17 on paper, constantly adding 17 each time until you reach the solution there. It might be a good idea if you have big values here to just write out a bunch of the multiples and doing the calculation. My final answer for this question over here is 25%. All right, going to end with that question for this video over here. I think that's pretty good. You can work on the signed numbers and continue with this for the next one, but hopefully you found that content helpful. And if you did, please hit that like and subscribe button and let me know if you want me to make any questions similar to any of the individual topics in this video.